That's okay. All right. Okay, so let me share my screen and we'll get started here. All right, so it says start by listing all 9 candidates, including their Z values. So I take that to mean that they want you to check the corners of the box here.
Okay.
Like, and it's 0, 0, 0, 6, 5, 0, and then 5, 6. And then we're going to evaluate these into the function here. So I'm going to set something up on my side to do this quickly, but I just need a moment to do that because I assume you don't have these yet. So 3. All right, so I'm going to start filling in these answers. Do you know if your WebAssign allows you to check just the ones that you've, just the ones you enter, meaning like doesn't check all of them so you don't lose your.
Yeah, like if I just submit one, I can like press submit and it will check if it's right.
Yeah, it doesn't like take away the attempts on the ones that you did not submit.
Yes, correct.
Okay, okay. Okay, so these are my numbers, and you're just plugging these back into the function there. Maybe check those. I know you've got some familiarity with this, so that should be fairly straightforward. So the next task here is to take partial derivatives. That's really where the class starts. You got to take a partial derivative of this function up here with respect to x,
Okay.
and that's to do part 5. Find the 4 boundary points. Okay, so that's 6x. Now this minus 2xy, that's probably the first one where it's a little bit complicated. You treat the y like it's a constant, so it becomes minus 2y, because it's minus 2y times x. So you treat the y like it's a number, and then if it's just got a y, it's a constant, minus 6, like that. And then you similarly need to find the partial derivative with respect to y, which means doing the same thing now, except it's with respect to y. So 3x squared has no derivative. Minus 2xy becomes minus 2x plus 8y minus 20.
And then you set those equal to 0.
Set both equal to 0, and you get a system of equations. And if you don't care how we solve them, I'm going to use a matrix method. If you need to solve these like by showing work, you would use elimination or substitution or calculator. I always like calculator.
Yeah.
When there's an option. Are your exams through WebAssign, do you know?
No, my exams are in person, but all of my
wow.
work is on WebAssign.
Okay, so should we, do we need, let me know if we need to review anything on this, but x ends up being 2 and y ends up being 3.
Okay. Yeah, I did that. I did that the system of equation way. Okay.
Okay, so then that's number 5, where you have to then find the z value by putting 2 in for x and 3 in for y.
Okay.
Pull up my a little script here to do this. So 2 and 3, and it gives you negative 26.
So it would be 2, 3, comma negative 26.
Exactly. Yeah, and that's box 5.
Okay. Okay. Yeah. So
now I'm struggling because I see your list of 4 corner points, and then after part 5 it says find the 4 boundary points and order your answers from smallest to largest x.
So I don't know if this helps, but you sometimes what we did in class was we like graphed it with the constraints. So like y would be um in between 0 and 6, and then like that would be like a boundary. I don't know if that helps or
Yeah. Well, I mean, so let me, yeah, I don't, so I'm guessing what they want at this point. Because this information right here plus this is generally enough to do it. Unless they want you to check now, like, for example, since X goes from 0 to 5, and what did Y goes from 0 to 6, it's almost like they want you to say, okay, well, assume X is 2, you would now try 2, 0, and then 2, 6.
okay.
And I mean, I'm pretty sure that's probably what they're going to want here. And then and then you would say, okay, well, Y is 3. So X is 0, and then 5, 3. Now we have to list these from smallest to largest X. So a little rearranging here. So it looks like this would be first. And then we need the Z value for each. Zero 3 gives you minus 14. Okay. So this is, I believe this is your 6, 7, 8, and 9.
Okay.
And it's like you pair up that X with, each of the Ys, and then the Y with each of the X's.
Okay. So how did you, so you just found the Z. You got the X and Y from like the Z or
From
like the derivative?
from the system. Remember we took fx and fy, and we got x's 2 as y's 3 as your critical point. And then you use, I believe you use one of those X values with the other 2 Y values at the edges.
Okay.
And then same thing with the Y, you get that Y. And that's kind of what I heard you say when you said you graphed it. Unless you meant something else. Because you could, okay, maybe you meant to take this X value of 2 and put it in here, and then find the, like if you put 2 in here, you get Y equals 3. So why would you do that? All right, I can also check this with the many available online options.
Okay, I'm just plugging in the answers real quick to see
Okay.
if it's correct. Sorry.
Yeah, you have to do a lot of typing. Let's see here.
Okay, so for 7 and 8, it says that 2 is right. So for 7, it says 2 is right. I'm sorry, 2 is wrong, 0 is right, 10 is wrong.
Okay.
Then for 8, it says 2 is right, 10 is wrong. Okay, wait, let me restart. Okay, so 6, it says 3 is wrong and -14 is wrong.
Yeah, so like the right hand side will be wrong if either of these are wrong.
Okay. So then for 7 and 8, 2 are wrong. And
That's
then
wrong, and that's wrong.
and then 3 is wrong. Yes.
It's like, so it's like we should have put 0, 0. Can you try 0 here and then 10 here? Because that was the first one that we did. I don't want you to run out of guesses, but
Okay, yeah, that did not work either.
great. Okay. So I found a better solution here. It says find x equals 0. Okay. So what it says to do is to put, like when we found that x is 2, it says to put that into the original function, which I think that's what you were saying. So let me grab the original function. And it says to put in that x is 2. And we'll see what we can do from here. So that gives you 12 minus 4y plus 4y squared minus 12 minus 20y plus 10. And then the resource I'm looking at says to take a derivative. No, yes, take a derivative and set it equal to 0.
Okay.
So the constants don't matter, but it's minus 4 plus 8y minus 20 equals 0. And so that ends up being y equals 3. And then, but we already knew that. Didn't we already know that? We already knew that. So why are we doing that here? Okay. This one. Y equals 3. Oh no, no, that's not right. So we don't put that in, we put in, sorry, this is not right. We don't put in that because that always goes that. It says to put in the x is 0, which is the, and that will do it. Okay, so let me see if this works, and then maybe it'll make some more sense here. So that becomes the first two terms are 0, 4y squared, that's 0, minus 20y plus 10. And then it says take a derivative of this, you get 8y minus 20 equals 0. So y equals 20 divided by 8, which is 5/2, which is 2.5. And so that's a new critical point. So when x is 0, we get that point right there. And so we can try 0, 2.5, which I think is why we, so can you try 2.5 in this position right here?
Yeah. Yes, that's correct.
Okay. So you do have to put in the original the original boundary, and then in this case, you get negative 15 for that position there. So then what we should do is put in x equals 5, because that's the other boundary.
Okay.
And the thing is, though, and this is where you gotta be a little bit more clever, is you can evaluate it right here, but that doesn't contribute to the derivative because it's just a constant. So you actually have to put it in here. So it becomes minus 10y. And then plus 4y squared minus 20y, because you actually don't care about the constants. Like if you do this on your own, when you get 75 here and you get minus 30, they just don't matter because you're taking a derivative. So the derivative minus 10 plus 8y minus 20 equals 0. So y is 30 over 8 or 15 over 4, which is 2.75 this time. So 5, 2.75. So this one's probably 2.75. You want to try this last position.
No.
No, didn't like that. Did I make a mistake here on this? 15 over 4. Oh, it's 3.75.
Okay, let me try
3.75.
3.75.
Sorry, that's
No,
really
you're totally
bad.
fine.
Really bad. Let's get this.
Yeah, that's correct.
And then this over here is minus 1.25 when you plug it in the calculator. Okay, so now we have to do this for y equals 0. And we only, like, this goes to 0, so don't care about that. This is 0. Minus 6x, that's 0. And you can add in the constant, but again, the derivative of a constant is 0, so you really don't care about that. You take your derivative, you set it equal to 0, x is 1. So 1, 0 is what we're looking for. And that's probably, this is probably should have been 1 here in number 7.
Okay. 3 squares.
And then this gives you 7 there.
Yes.
All right, so now we're cruising. We got this. We got kind of an understanding now of what to do. You put in y equals 6. So again, you get that 3x squared. This term it becomes minus 12x. We do need that one. This becomes a number. Minus 6x. This becomes a number plus a number. Derivatives of constants are 0. That's why I'm not writing them out.
Mhm.
And then you take a derivative, set it equal to 0, and it looks like you get x equals 3. So then that makes sense because this one should have been 3. 3, 6. And then the output is 7 again. The next one should go faster. We've got this down. To do the last part here, you're going to have to look at that list of numbers, and you're looking for the smallest number that's in Z, and then the largest number that's in Z out of your 1 through 9.
Okay, out of the 1 through 9.
Yes.
Okay, I can do that.
Yes.
'Cause that's
Okay.
just numbers.
All right, so let's move to 2. 2, in some ways it's good. It's a complete repeat of what we just did, and this should go a lot faster now since It's much clearer what to do. So the first thing you're going to do is evaluate at 0, 0. And that's where this stuff comes in. It's like you got to do it in the right order. 0, 15, 18, 0, 18, 15. So you're going to evaluate that up here. Do you want me to do that or move on?
I can do that.
Okay. So the next thing is now you got to take a partial derivative of this thing with respect to x. So you only care about where it has an x, which is right here. So it becomes, that's power rule 2x minus 3. Derivative of y is 0. Derivative of 20 is 0. You set that equal to 0. And that leads you to x equals 3. This one's actually very nice. Then you take a derivative partial with respect to y. So anything with x goes away because you don't care. Y, it's power rule 2, y minus 1. There is no derivative of either inside function. That's why we can just do that. And y is 1. So that's your number 5. Your number 5 is 3, 1, and then you can get that output value.
By plugging it in, right?
Yes. Yeah, and that's always back in the original. The original
Okay.
right here. The original. So that, yeah, z is the original. Okay, and this is where I messed up bad on the last one. So to do 6 through 8. Okay, you take you stay, okay, let's it's like this, let x equal 0, and you go back to the original functions. Let me go grab that. Okay, so when x is 0, like imagine putting a 0 in for x, you get minus 3 squared, which is 9, great, but you're going to take a derivative. So like you could write all this out. You don't need to, but you could. Okay, but you're taking a derivative. So this is a constant. Derivative of a constant is 0. So you take the 2y minus 1 again, you set that equal to 0, and you get y equals 1.
Okay.
And that's your first. Let me snip in those boxes.
And then you just plug those two numbers back into the original equation to get z?
Yes.
Okay.
Okay, so we don't know yet, but we're going to assume that these are our smallest ones, 0 and 1. But then you let x equal the other boundary. So if you scroll up here, you see the boundary is 18.
Mhm.
You let x equals 18. And then it becomes 18 minus 3 squared plus y minus 1 squared plus 20. And you take a derivative of this. But again, the derivative of the constant is 0, derivative of constant is 0. So again, it's 2 times y minus 1 equals 0. Y is 1. So it's 18. That's probably the last one. We'll get there. We'll get to that. So then you let y equal 0. Because you got to check all 4 boundaries. So if you go back, let me snip in this z. When you let y equal 0, you get 0 minus 1 squared, but again, it's a constant, so nobody cares. You don't care about it. It's irrelevant. So your derivative is just this, the 2 times x minus 3. So x is 3. So it's actually 3, 0. And then you let y equal 15, I think.
Yes.
Yeah, there it is. And so again, like it's very repetitive, but it's x minus 3 squared. Move this down. Plus 15 minus 1 squared, but that's a number. So you take your derivative, set that equal to 0, and x is 3. So it's 315. And if you've got the time, I would love to have you check at least the x and the y values in each of these.
Okay, yeah, I can just look
And then,
right now.
and if you got these, then you just put them in to get the.
Yeah. Let me see. Yeah, oh, yep, everything looks good.
Great. So then to do the last part, you need the z values. You need all the z values because you're going to look at all the z values 1, 2, 3, 4, 5, 6 through 8, and you pick the smallest, you pick the largest.
For the minimum, would it be the smallest x?
No, it's the smallest z value.
Oh, small z value. I even
Yes,
wrote that down.
yes,
Okay.
yes. It's a very like trivial thing because it's like which one's the smallest, which one's the biggest if you just look at that last column.
Okay. Cool. Okay, yeah, and I can calculate all of those later after.
Great. Okay, so let's look up the next one here. This next one's slightly different. It doesn't give you a closed interval for each x and y. It gives you it just says, you know, hey, it can be bigger, it can be smaller. All right, so what would I do here? I mean, why kind of like this tells me that y is 0. It's kind of an important thing. And then this one, if you set this equal to 0, you get 25 minus x squared equal to 0.
Mhm.
And that produces x equals plus or minus 5 when you solve it. And then we probably should take some partial derivatives. So like fx is 41, fy is 10. That doesn't help. So there's nothing kind of there that I can see. So I would probably be tempted without doing any more work here to just try 5, 0 and then minus 5, 0 in these positions and see if anything comes out from that.
Okay.
I'm sorry, actually, because these could be reversed. Let's actually plug in the number to get it. So let's plug these in to figure out which one is bigger and smaller.
Okay.
We'll do that. So this is 285. And this is minus 125. So I would probably try minus 50 and 50. And I wouldn't try the min or the max yet, just in case that way we don't use up one of our chances on those.
Okay. So -50 is correct, but 5, 0 is incorrect.
Is incorrect. Okay. All right. So what do we do now? So another sort of technique here is to put this 25 minus x squared in for y right here. And so it becomes 41x plus 10 times 25 minus x squared plus 80. And this is a good old like calculus 1 question where you have a function in one variable, so you just take a derivative and set it equal to 0. So your derivative here would be 41 plus 10 that just goes along with it minus 2x equals 0. And so we got 41 equals 20x. So x equals 41 over 20. And y, so to get y, I mean, you got to go back to your substitution. Maybe just try that number in here, 41 over 20. In that x position.
Yes, that was correct.
Okay. So to find your y value, your y is 25 minus 41 over 20 squared. Definitely want to grab a calculator for that. So it's 8319 over 400.
Okay.
And when you plug those in, you get you that number. So 41 over 20, comma 8319 over 400, comma 14,881 over 40. It's your X, your Y, and your Z. So that's going to be your max, looks like.
Okay. 41881.
Yeah, well, yeah, 14881 over 40.
Okay. And then just plug in that one for Y. Okay. That's
So I did a little bit of, we used a few approaches from the previous problem, but you can also make these equal and just sub them in and see if anything happens. There's not really, it's like a different method for each type of problem. The first two were the same, but this last one, and I think there was some wording there that said like you're guaranteed a min and a max, but you're not always guaranteed that either.
okay.
But they did tell us that's what worked out.
Okay, perfect.
Do you want us to go back and calculate some of the values for question 2?
Sure. That would save me some time as well.
All right, so I'm gonna just write a little script here, and then I'll start populating the boxes. You're welcome to check or use the computer to check. 30. They do make, they don't really, the TI doesn't really suited to doing 2 variable calculations. 1 variable, it's usually okay. So it's 225. So I think you got those there. So this one was 20. Let me know if you got these first 4 down so I can scroll past it.
Okay, give me 1 second. Okay, yes, I did.
Okay. We got the other ones here. 0, 1. All right. So it looks like that last one. Nope. The biggest one is up there at,
346.
it looks like the max.
Or 441. Whoops.
Yeah. Yep. And that you got it. And then the min 30, 29, 20. This looks like it's the min. That's kind of what your instructor wants to see when you're doing this on an exam, is labeling them next to it, or writing the complete summary that it has a min at X comma Y, and give those values.
Okay. Oh, whoops, I did it backwards.
Is there anything on question 1 that we should do again or finish up?
Actually, for number 2, I plugged in the minimum of 21 at 3,0, and it came out as incorrect.
Oh, because it's 3-1. There it is. I didn't look at that one. It's 3-1-20.
Okay. Okay, yes, now that's correct. All right. No, I don't think so. I'm just gonna plug in well, actually, this is just like kind of a question that I had from looking at my assignment. Will the minimum always be the critical point? Because it looks like in both questions, the minimum was the critical point.
The answer is no, but if you get a WebAssign exam, yes, it will be.
Oh, okay. That
A
makes sense.
quiz. Yeah. The people who write these, because I write stuff like this too, is you just generally use the same patterning of it. You may find your instructor gives you a WebAssign question. They just put it on a Word document and print it out too. So that might kind of clue you into what it should be. That it usually is the critical point.
Okay. Okay. So I did plug in the extreme values for for number 1.
Mhm.
And I did, which is really weird because it says that 2,3 is correct, but it says the minimum is not -2. That's because
Maybe
it's -26.
maybe
just-
it was typed in wrong. Maybe I typed in wrong. I don't.
No, that was my fault. It's because it's in like such a small box. I didn't see the 6. I
Yeah.
only saw -2. So. Okay, yeah, that looks like that was like the only thing I really need help with. Everything else I'm pretty I can understand, but I think I just have a lot of trouble with like determinants.
Okay. So my lessons for the summer are just a tiny bit are shorter. They're 45 minutes, but we can do some determinants for the last 5 minutes if you would like.
Oh, if you need to go, that's totally fine.
No, we've got 5 minutes. I keep them a little shorter because it's just,
Yeah.
but we can spend some time on, you said determinants.
Yeah, like
So
how yeah.
like there's 2 by 2 and there's a formula for these. And the determinant is AD minus BC. Now your calculator, are you allowed to use your calculator in this class?
Yes.
Calculator has a determinant. I would use that every time.
Oh, okay.
Okay. Now the reason you do a determinant most of the time is because you're trying to actually figure out if it has an inverse.
Okay.
So if you go to your calculator and it says invalid, I'm sorry, no. The determinant would never say invalid. If your determinant equals 0, so if your determinant of a matrix equals 0, it has no inverse.
Okay.
But it has to be a square matrix also. So like if you made a 2 by 3 and you try to calculate the determinant, it would tell you like error or invalid or something. You want to be careful that you know that you can only take the determinant of a square matrix.
Okay.
Only a square matrix. And it's in the 2 by 2, it's got a nice formula. For a 3 by 3 and beyond, it's probably better to do it with a calculator.
Okay.
Unless you think you want to do more with matrices to like if you plan on taking more math. Now we can do one. Do you think you need to do it by hand?
The 3 by 3, isn't that when you can like add the second, like the last row, and then you can do it like cross?
Yes, there's a few different ways to do it. I'm sorry, this is probably the example you saw in class. I would come up with a better one if I knew we were doing this. But you pick either a row or a column. Usually
Okay.
most students do a row. So you do 1 times the determinant of 5, 6, 8, and 9. You can see where I got those.
Mhm.
And then you take the next one too, and you like cross out the 5 and the 8. So you just do the 4 and the 7, and the 6 and the 9. But you have to alternate signs, and it comes from the this right here is position 1 1, and this is position 1 2. So whenever the sum of the position is odd, you negate it.
Okay.
If you don't remember that, just remember you have to, the middle one is negative of whatever it is. And then it's 3 times the determinant of these. So and I'm because I don't want to rewrite this, but like when you're doing 3, you cross out the row in the column, and this is what's left over. And that's what goes in the thing there. That this actually be a really good video for me to make, which I probably will do, to try and explain this. And so that's why you have to know how to do the 2 by 2, because you actually reduce the determinant of any size square matrix down to a 2 by 2, believe it or not. Like if you were doing this in software, you would just always write some code that got you down to a 2 by 2.
Okay.
This is 4 times 9 minus 6 times 7 plus 3 times 4 times 8 minus 5 times 7. And the determinant is always a number.
Okay.
Unless, well, we'll just leave it like that. Believe it's always a number. This always adds up to something. But use your calculator. And if you do have to do it by hand, use your calculator first to know what it should be, so that you're not surprised with each, step.
Okay. Thank you. Yeah, that makes a lot of sense. And I'll probably watch the video when I do my homework for it.
Excellent. Well, thank you so much for scheduling. If I can help you again, let me know. And I hope you're doing well. Hope everything's great.
Thank you so much.
All right, I'll send you the notes here shortly, and I'll see you next time.
Bye.
Bye.